Welcome everyone. I'm going to introduce the CoderGaze project from the Russell laboratory located in 202 Shore Center in the CSE department. So let me start by giving you a brief description of the sponsor. I am the primary contact for this project. My name is Dr. Bonita Sharif. I'm associate professor at the CSE department. I direct the Software Engineering Research and Empirical Studies Lab. This is located in 202 Shore. My office is in the same building, 103 Shore Center. My background, a little bit about me. I specialized in software engineering and I graduated in majoring in computer science, both at the BSMS and the PhD level. Now, the project I'm proposing here has to deal with the context of interviewing. But before that, we need to ask ourselves, what do we do as software developers as regular part of our jobs? There are three main things. We fix bugs, we implement new features, and possibly we refactor existing code. But the precursor to all of these things is actually reading code, right? So the general comprehension of code. So the question I want to ask is, what can we learn about software developers during a change task in the context of interviewing? And by change task, I mean fixing a bug, implementing a new feature, refactoring, and so on. So we'd like to gather new insights about the finer grained navigation patterns that developers perform while they're actually reading code before they even get to fixing a bug, right? You have to read it before. So we can use eye tracking in this context to actually capture these fine-grained navigation patterns of developers while they're actually reading code, which is not captured via keystrokes and mouse clicks, because you do not necessarily click something when you're reading it. You might, but not necessarily the case. So what can Gaze tell you? A lot. Okay, it can tell you things. It can determine if you're having trouble reading a certain section of the code. We can look at various metrics that give us these derivations. For example, we can look at how much you look at the if statement, for example. The overarching goal of this product, CoderGaze, is to assist technical interviewers to better understand what's going on in the developer's mind. How do they build their mental model to solve a specific software task during an interview? And one way you can do this is by recording the interviewee as they're doing the task. Now, this is important. You're doing it as they're doing the task, not in retrospect, because retrospective studies sometimes don't always work because people tend to misreport or forget to report what they actually did while they were doing the task. Targeting mainly software companies, but also recruiting companies, eye tracking companies that can sell this product to software companies and so on. So there is a lot of impact here that built correctly we can have in the software development industry. So if you don't know how an eye tracker looks like, these are some of the eye trackers here that I have. We will be working with trackers that are called remote trackers. They're called remote because they don't actually touch you. They're just positioned under the screen and they collect your data. An example of fixation data on a small snippet of code. A C code here, and you can see you have the circles representing the fixations that people made, this developer in particular made when he or she was reading the code. This is a little different from how eye tracking has been used in marketing, for example. The areas of interest that we are looking at is very different from marketing. For instance, the picture you see in front of you has an advertisement on the right that shows that people are mainly interested in seeing if people look at the baby's face or the shampoo bottle or the heading. But in our case, as software engineers, we don't have such areas of interest. Our areas of interest are basically tokens, right? The source code tokens. So you can see I've color coded them on the left where maybe we're interested in the line, but not necessarily. We might be interested just if people looked at, let's say, the predicate n greater than 1, right? And we can get to that. in our use case. So the current problem with software engineering, for software engineering rather, with current eye tracking software is that everything that you need tracked needs to fit on one screen. There's no scrolling support. You cannot switch between files. You have to do a ton of post-processing to actually get longer snippets of code tracked. So that's clearly a disadvantage because people usually do not write code that are 10 lines long, correct? Our software is tens and thousands of lines long, and you switch between files and so on. So what we have done is we have developed this CoderGaze basic application that actually connects to a tracker, maps this XY coordinate the tracker gives us to these lines and columns that you see in code within an integrated development environment such as Eclipse or Visual Studio or Atom. And then it produces the token, process it towards some functional goal. And I'll talk about what our functional goal is here. So we have an existing CoderGaze application, the initial prototype that works and is fully functional, but we need to expand on it. Functional goal. So this is a client-server architecture. We have a server, we call it the core, the CoderGaze core. Connects to a bunch of plugins, clients. In our case, in this project, you will mainly be working with Atom. Okay, it's built on top of Electron, I believe. And then, so basically your core gets the XY coordinates that your eye tracker gives you, that of what you're looking at on the screen. The plugins take that XY coordinate, map it to a line column. And then finally, at the end, you get the token that the main features. So we want to support a particular tracker. It's called the Smart Eye Tracker. And the main initial work for this began last year. The API of this tracker is in C++. Our application was in C#. So we need to somehow build a DLL that connects to this C++ application. So that was where we stopped last year. We need to extend the Atom functionality to record the syntactic category of the token being looked at. In other words, is it an if statement, a while statement, a predicate, and so on. Then we do a short test, and this data can be collected by my team as well. We just ask people to do a simple bug fix task on some application. We use the core and plugin to collect data, and then the main functional goal of this project is the interviewer's web dashboard. This is basically visualizing the eye tracking data based on certain queries. For example, did the developer look at the variable total cost? I'm just making these up for this presentation, but maybe total cost is vital to be looked at in order to fix the bug, right? And if they didn't even look at it, that clearly means they did not understand the problem, right? So the process, remember the thought process, the mental model that the developer is going through while they're processing this task. You can also have custom queries on eye tracking data. So let me quickly talk about the inputs and outputs of this interviewer's dashboard. So that is the main outcome of the project, besides supporting the Smart Eye Tracker that is half done. So this is a web application. The input you can assume is given to you. They are XML gaze files that the interviewee has gone through a particular task. So an interviewee comes in, they are given a bug fixing task in Atom. They complete the task, we record the gaze data. That's the XML file that is as input to give that's sent as input to this dashboard. There could be other inputs that the interviewer specifies, like certain parts of the code that were relevant, and various other queries. So for example, you could have canned queries like, did they follow a certain pattern while they were navigating the code? And other optional customizable queries. I can talk about those later on with the teams. The output is a visual representation as well as a textual, when I say textual, I mean a tabular representation of what the interviewee looked at. Okay, you should be able to also compare gazes between developers. So if two interviewees came in and did the exact same task, we would have two input files, two XML gaze files, and we want to be able to compare what are the similarities and differences between interviewer A and interview task. I do have a team that you'll be working with. These are some of my students, and I have some others that are not in this picture. Cole in the blue shirt would be our main development lead in the project, and he can assist you along with myself. So there is a lot of impact to this. Imagine I'm just going to play this. This is Eclipse, actually. Um, and you can see here, this person was looking at this is a JabRef system in Java, but they were trying to fix a bug in this. This is from an actual study we did a few years ago. And you can see these little fixations that show you the exact token they're actually looking at. In this case, you have 3 fixations on con.weightx, right? And then the process of how they navigate between it. So given this data, we can try to infer mental models of developers. And for instance, we can even seek to answer the question, what makes a novice, and how are they different from an expert? Or how does a novice get to become an expert? Because every expert was a novice at one point. So these are still open-ended questions that we're trying to address. So given that input, you can imagine I've shown you some visualizations here that are um, done after the fact. Obviously, we want to do this in the dashboard on the fly for this project. But you can see here, the x-axis shows the time, and the y-axis shows you the line that the person looked at in time. So you can see how they started on line 546, read that if statement and then went back to line 533 on top, and then went back and forth and tried to understand. And you can see most of the time is spent on the if statement that's checking for letter or digit, right? Because that's the more complex part of this code. Another example of a visualization that could be done is where you could color code. You could have the code itself and have heat maps on specific tokens behind it, because it's not as simple as just taking the data and outputting a bar graph, because there's a lot more than just doing that, because they're not short code snippets. They're lot. So there are some design decisions that need to be made here. All right, and that's the main gist of the project. Thank you for watching.